Hello everyone, welcome to my YouTube channel. My name is Rishi, and in today's video we will explore some design and architecting principles which are used very extensively in software design and architecting, and these principles are called solid principles. As the name indicates, solid, so these principles in fact give a very solid foundation for a software in long term so that the software is maintainable and error free in the long run. Solid principles are a set of 5 design principles which were coined and popularized by Robert C. Martin, popularly called Uncle Bob. So these are the guidelines for writing a clean, maintainable, and extensible code which can be further scaled up to any size, and thus these principles give a very good solid foundation from the beginning itself, from the conceptualization phase itself. If you follow these principles, mostly you are sure that you will have least of the problem when going for further modifications and scalability issues. So these are not actually the design patterns in itself, but they are the guidelines to implement to the design and architecting a software. So what are those 5 solid principles? So first one is called single responsibility principles. So even in a perfect object-oriented class design, it is often found that the class is very lengthy, though it contains only the relevant data and functions to an object, but still it is very lengthy. The class is doing too many things at a time. So if we are supposed to change one function of it, there is a possibility that other functions may get affected. And in order to fix one function, another function may stop working. And then we have to fix the another function. And when fixing another function, a third one may get affected, or maybe the previous one which we just implemented, that itself may get affected. So this way, in a class which is very lengthy, we end up into a series of fixing one thing and then creating bug into another part of the code, then fixing this bug, then creating another bug. So this endless loop is expensive and it consumes a lot of working hours, and it doesn't allow the software to become stable even after doing several rounds of fixing bugs, and fixing bugs. So single responsibility is like having a smaller manageable piece of code. This should be touched upon only for a specific functionality. Okay. Now coming to the second principle, open close principle. So open close principle, what does it say is class should be designed in such a way that it should be closed for future modifications but open for extensions. Means if someone want to add a functionality to the existing code, the existing class should be subclassed and those functions should be added into the subclass rather than changing the code of the existing class which is already developed, well tested and running all right into production. Now, third principle, list-scope substitution principle. In an object-oriented design, there will be a lot of inheritance. Superclass, subclass, subclass. 2-level, 3-level, 4-level inheritances are very common in object-oriented programming. When you are designing the classes and when you are subclassing, ensure that the functionality which is implemented by the parent class is not modified by the subclass. Otherwise, what will happen in an object-oriented design, a subclass object can be referred to as the parent class object. It can always be used in the parent class object name. So if someone tries to call the functionality which is implemented by the parent class, and if subclass has already modified by overriding the methods in such a way that it is entirely changing that part of the code, then the behavior will change. So this will become more clear when we dive deeper into by looking at the code. Okay, so I'll just, this is a top level brief idea. Coming to the fourth point, this is interface segregation principle. What interface segregation principle says is, it is very similar to single responsibility principle, that the interfaces should not be made very big. Interfaces should contain only closely related methods which function together and complement each other for a specific functionality. If you are having methods which are not closely related to each other, then what will happen? That the classes which are implementing these interfaces, they will unnecessarily be creating empty stubs for the methods which are not relevant for their implementation. So segregate means make more than one interface if there are too many unrelated functions are there. Then the last one is the fifth one, dependency inversion principle. So the last one is dependency inversion. The dependency inversion will be more clear when we look at the code. Describing it without code will be very difficult to grasp. So where does solid principles fit? Solid principles fit into design level, help in structuring classes. At the architectural level, it defines the interoperability of various modules. As I said earlier, these are not strict design patterns, but these are the guidelines which govern the entire design and architecting of the software.